All right, so in number 2, if I drag a vertical line across this graph, I get that this graph does actually pass the vertical line test. It is a function, so I'm going to circle that it's a function. All right, the x-intercepts are where it crosses the x-axis. So we cross at the x-axis here and here. So it does have x-intercepts, and there are 2 locations. My first location is -3, 0. My second location is 5, 0. All right, y-intercepts. We do have a y-intercept here. It crosses at this point here, so I'm going to circle yes, and my y-intercept is at the point 0, 90. Okay, so an absolute minimum. We do not have an absolute minimum because this graph goes on forever and ever in the downwards direction. So I'm going to say no, and then I could cross off my line or just leave it blank. Same with an absolute maximum. We don't have an absolute maximum because this is going to go up and up forever. Now, even though we don't have an absolute maximum or minimum, we do have relative maximums or minimums. A relative minimum is going to be a low point on the graph, even though it's not going to be your absolute low point, but we do have a low point on the graph. It is the point -3, 0. And a relative maximum is where we have a peak on the graph, and so we have this peak here, which is at the point 2.5, which I'm going to write as a 5/2, because when you type this into the Google form, I'm going to make you write it as a 5/2. And then the y value of 150, that's our point there. So my domain, this keeps going left and left and left and right and right and right. So my domain is -infinity to infinity. My intervals of increasing. I'm looking for the x values as to where my y values are increasing. So if I start at the left part of the graph, right now I'm going down and down and down and down until I hit the x value of -3. And then once I hit the x value of -3, I start to climb. I'm climbing, 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 climbing until I hit the x value of 2.5. And that's when I start to decrease and go down and down and down again all the way to infinity. So my intervals of increasing are the red part of my graph, and that is in between the x values of -3 and 2.5, which again I'm going to write as 5/2. Where my intervals of decreasing are my yellow portions. My first yellow portion extends from an x value of -infinity to an x value of -3. And my second decreasing part is my second yellow portion, which is an x value of 5/2 all the way to an x value of infinity. All right, my range. Well, this goes up and up and up forever and down and down and down forever. So my range is -infinity to infinity. All right, intervals, when my graph is positive and where it's negative, I'm talking about the y values. So my y values are positive, and I want the x values for where the y values are positive. My y is positive at all of these points here, and actually it's not positive at -3, I apologize, because at -3 it's a y value of 0. So my y values are positive when x is -infinity to -3. But then my y values start being positive again from -3 all the way to an x value of 5. And then my y values start to become negative after the x value of 5. So that's 5 until the x value of infinity. All right, end behavior. So on the left side of the graph, that's when x is approaching -infinity. When x is approaching -infinity, my y is approaching infinity. And then as x approaches -infinity, my y value is going down towards -infinity. as x is approaching positive infinity, my y value is going down and approaching negative infinity. And then, does this graph have symmetry? No. If we folded this graph in half, it would not match exactly. So, no, it does not have symmetry. Moving on to my next one here. This would be a function. It would pass the vertical line test. Now, X-intercepts, recognizing that this is an exponential function, or it creates the type of graph of an exponential function, this is going to get really, really close to the x-axis, but it's not actually going to cross the x-axis. So there are no x-intercepts, therefore we don't write a location. Now the y-intercept, we do have a y-intercept. It crosses the y-axis at the point 0, 1. All right, an absolute minimum we don't have because it's going to go all the way towards as close as you can get to 0, but it's never going to hit 0, and that's going to go on forever and ever and ever because you could have 0.000 repeating all the way up to 1. So no absolute minimum. And this graph goes up and up and up forever, so there is no absolute maximum as well. And relative minimum, there is no low point on the graph, and relative maximum, there is no high point on the graph. Now my domain here, it extends to the left and the right forever and ever, so my domain is from negative infinity to infinity. My intervals of increasing, if I start at the leftmost part of the graph, my y is going up and up and up, and it increases forever and ever and ever. So that's in between, my y value is increasing in between an x value of negative infinity to infinity. Intervals of decreasing, there is none. My range is going to be from 0. It's never going to hit 0, but it's going to get close to 0. So that's why I put parentheses 0, because it doesn't include 0, and all the way up into infinity. Intervals where the y value is positive, well, that's everywhere. So that's from negative infinity to infinity. Intervals where the y values are negative, that's never, so none. And then end behavior. So as x approaches negative infinity, y is actually approaching 0. So we'll write that. Oops. And as x approaches infinity, y is also approaching infinity. And then lastly, does this graph have symmetry? No, if we folded this graph in half, it would not match exactly. All right, moving on to number 4, which is our last problem. We want to determine if this is a function or not. Well, if I drag a vertical line across the graph, this is not going to pass the vertical line test, so it's not a function. The x-intercepts, the only place that this intersects the x-axis is at 0, 0, so we do have x-intercepts. It's just 1.00. The graph crosses the y-axis at 1 point as well. That's 0, 0. All right. Absolute minimum, there is none because this graph is going to get wider and wider and wider, up and up and up and down and down and down forever. Absolute maximum, there also is none. Relative minimum, there's none. Relative maximum, there's none. There's no peaks or dips in this graph, so that's what we mean by relative maximum and minimum. Now in my domain, I start at 0, and that includes 0, so I'm going to do my brackets, and it goes all the way to the right, so it goes all the way towards towards positive infinity. Intervals of increasing here, so if I start here, as x increases, y is increasing on this side, so that is an interval of increasing. That goes from the x value of 0 all the way to infinity. But if I start here and I go down, as x is increasing, y is also decreasing on this part of my graph. So when x is 0 and in between 0 and infinity, y is also decreasing, depending on what part of the parabola you're looking at. Your range, well, this is going to go down and down forever and ever. It's going to continue to get wider and up forever and ever. So this goes from negative infinity to infinity. Intervals where your graph is positive. Well, on the pink portion, my y values are positive, and that is when you have an x value of 0 in between 0 and an x value of infinity. And on the blue portion on my graph, that is actually when the y values are negative, and that's also between an x value of 0 and infinity. And my end behavior. As x approaches 0, because that's the leftmost point, y equals 0. And as x approaches positive infinity, y is approaching positive infinity and negative infinity at the same time. And then does this graph have symmetry? It does. If I folded it in half along the x-axis, it would match exactly. So yes, it has symmetry, and it is along the x-axis. All right, that brings us to the end of this lesson.